Hello and welcome to The Explainer. Today, we are getting into something that is absolutely fundamental to cloud security, but honestly, it trips people up all the time. We're talking about how Azure Firewall handles network traffic. And trust me, once you get this, you'll be in a much better position to really lock down your cloud defenses.
I want you to think about this for a second. Back in the day, we had data centers, right? With actual walls, key cards, security guards, a clear perimeter. But in the cloud, all of that is gone. It's just this vast open digital space. So, the big question is, how do you protect your most valuable stuff in a place with no walls? That's the challenge we're tackling today.
So, before we dive into the technical nuts and bolts of the firewall itself, we've got to take one step back. We need to answer a more basic question first. Why is it so incredibly important to control traffic in the cloud to begin with?
Well, the simple truth is that the cloud isn't insecure. Not at all. But it is wide open by default. Those old boundaries we used to rely on, they've vanished. So it's on us now. We have to be the ones to build the virtual fences, to draw the lines in the sand, and to create our own secure perimeters to dictate exactly who can talk to what.
And listen, this isn't just a good idea. It's straight from the playbook. The Microsoft Cloud Security Benchmark spells it out for us. You've got to segment your network. You need a firewall at the edge, you have to control that internal or east-west traffic, and you absolutely must log everything for when you need to investigate. These principles are basically our North Star for cloud security.
Okay, so to actually enforce all those principles, we need a tool. And in the world of Azure, our go-to tool is the Azure Firewall. The main trick up its sleeve, the secret sauce that makes it all work, is a process called Network Address Translation. You've probably heard it called NAT.
All right, so the firewall's secret weapon is NAT. Let's pull back the curtain on what can feel like some kind of dark magic. It sounds super technical, but I promise the core idea is actually pretty straightforward once you see it.
So what is it really? At its heart, NAT is just a remapping service. It grabs a packet of data, takes a look at the address info in the header, and basically just rewrites it before sending it on its way. You can think of it like a mail forwarding service for the internet, or even like a secret identity.
You know, the best way to get this is the receptionist analogy. So picture this. A call comes in from the outside to your company's main public number. That's your firewall's public IP. The receptionist, that's your firewall, picks up and asks who the call is for. The caller says, "I need to speak to someone in sales." The receptionist then patches them through to a private desk extension, a number that nobody outside the company even knows exists. That is exactly what Azure Firewall is doing, just with data packets instead of phone calls.
Okay, now that we have that foundation, let's look at our first real-world scenario, how we handle traffic from the public internet that's trying to get into our nice secure network. This particular process has a name, Destination NAT, or DNAT, and the name really gives away the game, right? Its whole job is to change the packet's destination from the firewall's public IP to one of your server's private IPs. This is our virtual receptionist live in action. Let's follow a packet on its journey here. See on the left, the client out on the internet? It sends its traffic to the firewall's public IP. That's the destination it knows. But then the firewall does its thing. Now look at the right, the final server's point of view. The destination is now its own private IP. But here's the really crucial part. Look at the source IP. The server doesn't see the original client. Nope, it sees an IP address from the firewall's own subnet. The firewall is acting as a true middleman, protecting both sides.
Now, this behavior has some really direct practical consequences. First, when you're looking at your server logs, you're gonna see traffic coming from the firewall's subnet, not the original client. Second, the original source port is usually kept the same, which, let me tell you, can be an absolute lifesaver when you're troubleshooting. And finally, and this is a big one, your server's network security group, your NSG, must have a rule that allows traffic from the Azure Firewall subnet. If you forget that, the firewall forwards the packet, but the NSG just drops it.
Okay, so that covers traffic coming in. Now let's flip it around. What about traffic that starts inside our network and wants to go out to the internet, or even traffic that's just moving between our own internal networks? This right here is where things get a little tricky, and it's where most of the confusion around Azure Firewall comes from.
So for this, the firewall does what's called source NAT, or SNAT. It changes the source IP of the packet to its own public IP, which hides your internal server addresses from the outside world. But, and you have to catch this is the key to everything, how it does that SNAT completely changes depending on whether you're using a network rule or an application rule.
This is the absolute critical difference you need to burn into your memory. Network rules are, well, they're smart about it. You can think of them as doing conditional SNAT. They'll only do it when it makes sense, like when traffic is headed out to the public internet. But application rules, they're different. They perform absolute SNAT. If traffic matches an application rule, it will be snatted, period. It doesn't matter if it's going to the internet or to the server right next door, it gets snatted.
And hey, don't just take my word for it. This is straight from the Microsoft tech community. They state it explicitly. Even if you try to tell the firewall, hey, don't SNAT traffic going to my private networks, if that traffic hits an application rule, that instruction gets ignored. The application rule always wins. This is probably the single most important behavior to understand when you're trying to figure out why your outbound traffic isn't working as expected.
All right, we've gone deep. We've talked DNAT, SNAT, network rules, application rules. It's a lot, I know. So let's zoom back out and connect all these technical details back to the real world. Why on earth does any of this actually matter?
It's a totally fair question. I mean, why get so obsessed with these details? Why should you care about the difference between a conditional SNAT on a network rule and an absolute SNAT on an application rule? How does that actually help you do your job?
It matters because understanding this changes everything about how you manage your network. It means you get accurate logs because now you know which source IP to actually search for. It lets you troubleshoot effectively, tracing a connection from start to finish without getting confused by a surprise IP change. It gives you rock-solid security because you know for sure how your network appears to the outside world. And maybe most important of all, it allows you to write firewall and NSG rules that just work the first time because you can finally predict what the firewall is going to do.
So, when you get right down to it, network address translation, it isn't just some dry technical feature. It's the language your network uses to talk, to hide, and to protect itself. And by mastering these behaviors, you're not just clicking buttons in a portal. You're actually learning to listen to what your network is trying to tell you. Thanks so much for joining this explainer.